Okay, section 2.3 is about determinants and a multiplicative inverse of matrices. First of all, we're going to start with the determinant of a matrix, and we're finding the determinant of a matrix in order to solve matrix equations. And we're going to need the determinant in order to write the inverse of a matrix. So, the determinant of a matrix is where we multiply the upper left times the bottom right. So A1 times A times B2, and we subtract it from the other way. So we're going to cross multiply. All right, we're going to subtract the two. So we're going to multiply A1 times B2, and we're going to subtract B1 times A2. So this really isn't too terribly difficult. We're going to cross multiply the determinant. Sometimes you note it as DET in front of it, or it can be denoted as an absolute value sign. So it could be written as the absolute value of negative 2, 4, 3, 7 as well. That means find the determinant if it's just a straight line and it's written in matrix form. So to find the determinant, we're going to take A1 times B2. So we're going to cross multiply. So a negative 14 minus 3 times 4, which is 12. So the determinant of this matrix right here is going to be negative 26. Okay? Now that's a 2 by 2 matrix. A 3 by 3 matrix is a little different. And first of all, I want to start off telling you what the minor of a matrix means, of a 3 by 3 matrix. All right, so I'm saying the minor of A1. All right, the minor of A1 is if I cross out the lines where the column that A1's involved in and the row that A1 is involved in, and I write the leftover matrix. So B2, C2, B3, C3. That is the minor of A1. The minor of B1 would be where I cross out the column and the row that B1 is involved in. So I cross out the column and the row, and I write the resulting matrix. So the minor of B1 is the absolute value of A2, C2. I'm just writing the matrix what's left over from left to right. And then A3, B3. All right. So this is going to help us find the determinant of a 3 by 3 matrix. All right. So like what this sentence is saying here, to find the determinant of a third order matrix, we expand the determinant by minors. All right. So to find that determinant of a 3 by 3 matrix, we're going to span this thing by minors, like I said. And so we're going to expand it by A1's minor. So we're going to go ahead, it's going to be A1 times the determinant of, let's cross out A1's column and row, B2, C2. That should be, sorry, B3, C3. Those are written wrong. This should be B3 and this should be C3. My bad. Okay. And then we're going to subtract then the minor of B1. So we're going to cross out whatever we see in B1, its row and column. So minus B1 times the determinant of its minor, A2, C2, A3, C3. And then we're going to add to it C1's minor, the determinant of C1's minor. Okay, so we cross out the row and the column that C1's involved in. We write C1 in the outside, and we take the determinant of A2, B2, A3, B3. And I realize with A's and B's and C's, this may seem a little confusing. I'll make more sense of it out of here, this example right here down at the bottom. Okay, so we're going to do expansion of minors, expansion by minors, all right? And we're going to find the determinant of this 3 by 3 matrix. So we said it was A1, which is negative 2, so we're going to write negative 2, times the determinant of its minor, so we're going to cross out its column and its row, and we're going to rewrite the matrix. 3, 2, 5, 4. All right? And the thing about this, the determinant has a rule. It always goes, this is a negative 2 out front, but it always goes plus, minus, and the next one's going to be plus. All right, so it'll be plus the first major, so a positive first minor minus the second minor plus the third minor and so forth. Okay, So like I said, the next one, then we're going to say we're going to take B1 times its minor then. So we're going to cross out the row and the column. All right, we're going to write B1, which is 4. Take the determinant of its minor, which is 4, 2, negative 1, 4. Then we're going to add C1. C1's minor. Okay, so we're going to write C1, which is negative 1. That's right here. On the outside, we're going to cross out its row, its columns, and we're going to write the resultant matrix. And it's going to be 4, negative 3, negative 1, 5. And I drew over top of my C1, my bad. So this should be a negative 1 out front. Now, what these straight lines mean is that means the determinant. We just learned how to take the determinant of a 2 by 2 matrix. We multiply, we cross multiply, we look diagonal, and we subtract. So we're going to have a negative 2 times negative 12 minus 10 minus 4 times, let's see, 16 minus a negative 2 plus negative 1 times 20 minus a positive 3, because what I was doing is I was cross multiplying and subtracting. Okay, and now I combine like terms and then I multiply. Negative 12 minus 10 is a negative 22, and we still have a times negative 2 out in front. Minus 16 minus a minus 2, so cross the line, change of sign, is going to be a negative 4 times 18 plus negative 1 times 20 minus 3 is 17. All right, so negative 22 times a negative 2 is a positive 44 minus 4 times 18, which is 72, plus a negative 17, so minus 17. We combine those, and we get 44 minus 72 minus 17, and we get negative 45. So that's finding the determinant of a 3 by 3 matrix. Okay, feel free to watch that again if you got lost somewhere. Try to do that yourself. Figure that thing out. If you still have questions, please come find me and ask me a question about that one. Now, we're to the identity matrix. I told you the identity matrix of a, for addition was a 0, 0 matrix, 0, 0, 0, 0, right? Well, in multiplications, it's a little different. It's 0, 1, it's 1, 0, 0, 1. So 1's going diagonal is the identity matrix. And what that does is that if I multiply any 2 by 2 matrix, and I multiply these two together, I'm going to get the same matrix. That's what identity matrix means. Okay, so I multiply row by column. It's going to be 2 times 1 is 2 plus 1 times 0 is 0. Anything I multiply, any matrix I multiply by this identity matrix means that I'm going to get this same matrix back. It's just like the identity of multiplication. Multiplication is 1. 3 times 1 is 3. 4 times 1 is 4. This is the identity of multiplication because the thing that we multiply it by is when we multiply it by that same thing, we get the same answer. We get 3. All right, so that's what the identity means. All right. So where this comes into play is if we want to solve a matrix equation to get rid of, maybe we want to move this matrix to the other side, like in algebra. Like, so we want to divide it over to the other side. Well, we multiply by its inverse, just the same like if I have, sorry, I messed that up. If I have, let's see here. If I have 1/2 x equals 2, when I solve this, I'm going to multiply by its inverse of 2 over 1, or its reciprocal, right? 2 over 1, so I can move it to the other side, and I get x equals 4. So we're going to do that same type of thing with matrices instead. To find an inverse, now this is different than finding a determinant. We will use a determinant to find the inverse. All right, but to find the inverse of a determinant, this is a 2 by 2 determinant, the inverse, a negative 1, this means the inverse. The inverse is going to equal 1 all over the determinant times, and all we do, this is easier than what it looks. All we do is we switch. Notice this is A1 and B2. All they did is they switched spots. That's it. We flipped those spots. And then all these two, they stayed in the same spot, but all they did is they changed the sign of them. That's it. All you have to do is find the determinant So it's going to be 1 over the determinant times a new matrix where these two just flip, and we change these two signs, and that's it. All right, so I'll give you an example here. Find the multiplicative, I can't ever say that word, inverse of -1, 4, 3, and 2. All right, so like I said, the first thing we do, we're going to go, the inverse is going to be 1 all over the determinant. So the determinant, we multiply diagonally, so -2 minus 12, which is a -14, times, and the rest is very simple. We just switch these two, -1 and 2. We just switch them. So on the top, I'm going to write 2, on the bottom, I'm going to write -1. And we change the signs of these. So it's going to be -4, -3. And that's it. That's all finding the inverse is 1 over the determinant, and then times our new matrix. So what we could do is we could multiply this 1 over -14 through all of this, and then we'd have just a matrix left over, and that's all we have to do. All right. So I think I have one more example for you. I know we're getting long here, but hold out for a couple more minutes. I'm going to show you how to solve a matrix equation now. All right, so this is the fourth way to solve a system of equations, is using matrices. All right, I can rewrite this system of equations using matrices. And watch this. I'm going to write 2, 3. That's my x and y. I'm just going to take out my x's and my y's. Then I'm going to write -4, 5. That's one matrix. And then as another matrix, I'm going to write x times y. If I were to multiply 2 times these two matrices, I'd get 2 times x, is row by column, so 2x plus 3y, and it just is the same as this. And I'm going to set this equal to -1, -18 matrix here. So if I multiply these two, I'd get 2x plus 3y, and see how it's the same thing, and the same thing at the bottom, row by column, -4x plus 5y. That's how we can get away with writing it. Now, just like a regular equation, this is like saying I have, I don't know, 1/2 x equals -1. This is like your 1/2 here. We got to multiply by its inverse, something that'll get it back to its identity. That's what an inverse is. Identity is just 1, right? So we want to be left over with a 1x. Okay? We want to be left over with a 1x. So we want to be left over with the identity matrix. And how we get to the identity matrix is we multiply each side by the inverse of that function. So that means we got to find the inverse of this matrix right here, which we decided wasn't that big a deal. I guess I decided. You guys have no input on this video, I guess, but it's really not a big deal. We find the determinant. So we're going to go 1 all over the determinant, which is 2 times 5, which is 10, minus -4 times 3 is a -12. Cross the line, change the sign, is a +22. And then all we do, I'm going to go ahead and write +22 down here. +22. All right. And then all we did to find the inverse, remember, was to switch these two. So 5 and 2. And then we change the sign of these two, -3 and a +4. So we're going to multiply each side by these. When I multiply this by that, it's going to cross out. It's going to be the inverse. It's going to be 1. All right. So then, you know, in algebra, whatever we do to the left side, we have to do the right side. So we're going to have to multiply this matrix here by this matrix, and we're going to come up with our x and our y, and it's as easy as that. All right. One thing I do have to show you, because of our rules of matrix multiplication, this has to be multiplied on the left side. All right. It's a 2 by 2 matrix. All right. And this one is a 2 by 1 matrix. Remember that as long as these middle two are equal to each other, we could multiply them, and we're going to result in a 2 by 1 matrix. That was our rules of multiplication, matrix multiplication. So we got to multiply this thing on the left side. So if I go ahead and distribute my 1 over 22, I'm going to have 5 over 22, and then 4 over 22. We're going to go ahead and leave it as over 22 because we're going to end up adding stuff. And -3 over 22, and 2 over 22. And I'll multiply this by the left side because that's what algebra says. If I do it to the right side, because I did it to the right side and this thing canceled out, it became 1. So all I'm left over with over here is xy as a matrix. Okay, that's it. And I'm going to multiply now this matrix by -1, -18. All right, so when we multiply matrices, we multiply row by column. So I go 5/22 times the -1, which is -5/22, plus -3/22 times -18/22 is going to be a positive, and 18 times 3, when we multiply fractions, we multiply straight across. 18 times 3 is just 54, so 54 over 22. That's going to be our top column. I'm running out of room. I apologize for how messy this is. Our top guy, so, well, let me write it up here. We have XY as a matrix, and that's equal, my top row, my row by column is going to be, what's that, 49 over 22? -5 plus 54 is 49 over 22. Okay. And then, so that one's done. So then I need to do this row by this column to solve for my y, to get my last thing. It's going to be a 2-by-1 matrix. So -4 times 22 is a -4 over 22, plus -18 times 2 over 22 is a -36 over 22. And I'm left over with 40 over 22, -40 over 22, or let's see here, 20 over 11, -20 over 11. Okay, so it seemed like a lot more work, and it seemed like your elimination substitution might be easier, but I'd like you to learn this method too, get you more familiar with matrix multiplication. And what I ended up here with is x equals 49 over 22, y equals -20 over 11. All right, I hope I didn't miss a sign anywhere in there. Okay, but so that's how we solve using matrix multiplication. I hope this helps. If you have a question, please come see me about it. And also, you can go ahead and rewind this video and watch the parts that you don't understand. I hope this helps. We'll see you in class.